Hello everyone and welcome back to Just Finish Coding. My name is Sriram and this is the sixth part of the car chase series. In case you haven't watched parts 1 to 5, there will be a card for you right here. By the end of this video, you will have the player's obstacle collision completely ready, and you will also be able to make the car's shadow follow it around to make the game experience more realistic. Alright, to start with, we head over into the car sprite and create a new block. We call this obstacle border test. It is very important to click the checkbox which says run without screen refresh. The purpose of this block is to actually handle an error. Let us suppose that the car was to the right of an obstacle and then hit it. In most cases, we'd want the car to get thrown back to the right. However, let us suppose that there was also a border to the right of the car. In this case, if we move the car to the right, then it will go into the border and this will create a whole bunch of errors. So in the rare case that the border is very close to the player, we would want the car to move to the opposite side in which the border is. If the border is to the right of the car, then the car must move to the left, and if the border is to the left of the car, we must move to the right, regardless of which side the obstacle is on. Once again, like we did for the borders, we can use the side collision variable. We now create a variable called initial x for this sprite only. The purpose of this variable is to store the x position of the player temporarily. Initially, we set side collision to none. We set initial x to the x position. Until the car is no longer touching the obstacle, we change x by -1. The result of this will be the car moving to the immediate left of the obstacle. In this case, we check if the border is being touched. If it is, then we know that the border is to the left of the player. So, we set side collision to left. There is a possibility that this is not the case and that the border is on the right side, so we have to check that case as well. We'd now want the car to go back to wherever it was before. For this, we set x back to the initial x position. This done, we can repeat the same code again, except with a few minor changes. This time, we change x by +1 so that it moves towards the right. If we are touching the border this time, the side collision variable should be set to right. Nice! With this done, we also need to modify the car physics left and the car physics right blocks. At this point, they only check for collisions with the border, but we can make them check for collisions with the obstacles as well. To do this, we add in an OR operator within the NOT. This is very important. We repeat until not touching borders or touching obstacles. The same condition can be used for car physics left, so we duplicate that. Great, now we have to create the block which will deal with all of the obstacle collision possibilities. This function can be called check obstacle collisions. Within this block, we will nest all the other functions that we created and modified, like the obstacle border test function, car physics right, and car physics left. Of course, there's no point if none of the changes we make within these affect the main code, therefore we put in the block after check border collisions. Just like with the borders, there are three main possibilities. In the first case, the car could hit an obstacle by moving rightwards. In the second case, the car could hit an obstacle by moving leftwards. In the third case, the car could hit an obstacle straightly without moving. Let's program these cases one by one. In the first case, the car will be touching the obstacle and have its x velocity greater than 0. When the x velocity is positive, it means that the car is moving rightwards. By default, we think that the car should be pushed to the left. This will be correct except when the border is very close to the car. So, to make sure that the border is not close by, we use the obstacle border test function. After the function is used, the side collision variable will assume the side in which the border is on. If the side collision is none, then it means that the border is not close enough to cause errors. In this case, we do the default thing and use the car physics left block. Within the else statement, we check if side collision is left. If this is the case, then it means that the border is to the left of the car. Moving leftwards the normal way will lead to big errors. So, in this case, we use the car physics right block. In case the border is to the right, there is no problem since we will use the car physics left block. Perfect. With this done, we can duplicate the template and use it for the next two possibilities. In the second case, we check if x velocity is less than 0. When the x velocity is negative, it means that the car is moving leftwards. If side collision is none, then we do the default thing by using car physics right. We can actually leave the rest of the code as it is. If the border is to the left, then there's no problem as we will move the car to the right. If side collision is to the left, as in the case of the last else statement, then we do the exact opposite by using the car physics left block. Nice, let's now program the final possibility. In this case, the x velocity will be 0. As I mentioned earlier, this will be a straight hit. This is where things may get a bit tricky. The else code will work the exact same way, however the default code wouldn't make any sense. Which side should the car move towards in case there is no border nearby? To answer this, we have a simple condition. If the x position of the obstacle is less than that of the car, then we use car physics right. Otherwise, we use car physics left. Let's go through what's happening here. If the x position of the car is more than the x position of the obstacle, then it means that the car is to the right of the obstacle. In this case, we just throw in car physics right as we'd want the car to move rightwards. The else condition is pretty similar. If the x position of the car is less than that of the obstacle, then it means that the car is to the left of the obstacle. In this case, the car should veer to the left, therefore we use car physics left. That will be everything necessary for the obstacle collision. If you test out the program now, the car should collide perfectly with all of the obstacles. The collisions should also work as intended when the car is extremely close to the borders. Great! Before we finish, we can just code the car's shadow. This code is very simple and can be done with just a few lines of code. When the green flag is clicked, we show the sprite. This should be obvious as the car will be shown both in the lobby and the main game. Since the car will be shown all the time, the car's shadow should be shown all the time as well. After this, we get into a forever loop. We set the x position as the x position of the car plus 6. For the y position of the shadow, we set it to the y position of the car minus 6. Now at first glance, a person may just want to set the x position to the x position of the car and the y position to the y position of the car. This, however, would be a mistake because the shadow wouldn't be seen at all. To see a realistic shadow, a big chunk of it should be below the car itself, while the remaining should be at a small distance away. In this case, we are making the shadow position itself slightly to the bottom right. This will be the way the shadow appears if we assume the sun to be at the top left. For the direction of the shadow, we just set it to direction of the car. This should be self-explanatory. The shadow will copy every movement of the car, including the car's direction. After this, we go to the back layer and set ghost effect to 60. The shadow should obviously be below the car, so of course the shadow should be at the back layer. We also know that shadows are not completely opaque. They don't make the ground that they are on completely black, and a person can still make out what the ground is. The shadow is translucent. It doesn't cover the ground completely, nor is it completely transparent. A ghost effect of 60 brings this out pretty well. Alright, that will be everything that has to be done for this video. If you test the program out now, the car shadow should follow the car everywhere it goes. This is a great addition to the game and makes the gameplay a whole lot better. All that is necessary to finish off the game is the health bar and the background music. If you've enjoyed this video, please make sure you leave a like and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching and I'll see you in the next video.